Hi everyone, thank you for joining our webinar today. So we've just got a couple of people filtering in, so I'm just going to give it a couple of minutes before we officially start, so let people join the webinar. Great. I'm definitely seeing loads of people joining. So thank you so much for joining the webinar today. We're talking about South Africa's real-time coastal observation network. So I'm joined with people from SAEON and STS today, which is great to share their experience in building this network with us here at Sofar. So before I start this presentation, we would like to have questions at the end. So at the bottom of your screen, there will be a Q&A box. If you have any questions throughout the webinar, please put these in the Q&A box. And at the end, we'll be answering these questions. So we'll have a quick 10-15 minute session at the end where myself, STS and SAEON will be answering your questions. So if anything pops to mind during the call, please put them there. If we can't finish all of your questions within the allotted time, we will respond to you at the end via email. And likewise, if you have any questions that pop up afterwards, we know how it is. We can always forward on those emails to Andre and Tommy, and they'll be able to respond to you as well. So we'll be able to get back to you if your questions aren't answered during this webinar. Okay, so with that said, I will start the presentation now, and I'll give you a quick reminder towards the end about adding questions to our Q&A section. So I'm just going to give you a quick background about Sofar, who we are, what we do, and just to give you a bit of context so that SAEON and STS can take away their relationship with us and what we've been doing. So Sofar, an American-based company over in San Francisco. My name's Jasmine Eggleton, and I represent them here in Europe and Africa. Hence this relationship here with STS and SAEON. And we are an ocean tech company started in roughly about 2019 with a combination of two companies, Spoondrift and OpenROV. So we have very strong backgrounds in oceanography and technology. So that combination has been great, and we've been growing ever since, which is really exciting. So our fundamentals started with the Spotter platform. It is a buoy at the surface, which is collecting ocean data, and we're transmitting that in real time, either via cellular or iridium, so very much dependent on your location that you're operating in. It's a dual modem system, so you can switch between the two, which gives you that added flexibility. It's completely solar powered, so you don't need to change out any of the batteries ever. And there are things that we can do when you go to those higher latitudes. I know a lot of my customers do. And you can have data access either via a API or our online dashboard. And then everything's also stored all on the SD cards as well. They may be small, but they're very rugged systems. You can throw them out of aircraft and they can land in the ocean and start collecting data. That's how robust these little systems are. The spotter at the surface is collecting wind, wave, sea surface temperature, and barometric pressure at the surface. We use a GPS displacement data for our wave data, and then our wind measurements are derived. So we use the wave spectra combined with an algorithm to back calculate the effect of the wind on the sea surface. So using those known values to calculate those unknown values, which has been highly accurate, especially in offshore locations, which provide a large fetch. And then we output temperature and pressure as standard. We can also add real-time subsurface measurements as well. So we remove that temperature sensor at the base of the spotter and then plug in what we like to call a smart mooring. The smart mooring is a load-bearing power and communications cable in which we integrate subsurface sensors to get real-time data up to the spotter and transmit that in real time. So off the shelf at Sofar, we have temperature sensors. We have a bottom-mounted pressure sensor for water level monitoring. We have a single point current meter from Andera. We also have our new sensors, which is the hydrophone and the DO sensor. So these are two new sensors that are released at the end of this month, that are ready, available to pre-order now. And so we can do more acoustic monitoring, but also some more chemical monitoring with the DO sensor as well. So these are all the standard off-the-shelf sensors that we have at Sofar that you're able to see on our website, but also when you talk to your Sofar rep. We also have the option of a Bristlemouth dev kit, which is important for this conference here. Bristlemouth is an open source platform. It's been born out of Sofar, so all of the engineers working on Bristlemouth are Sofar employees currently. And so Spotter is the only platform that is currently hosting Bristlemouth. We're hoping this starts getting adopted for other people within the industry. It's open source, so it's easy for other people to start adopting. And the Bristlemouth Dev Kit on the right here is a tool to integrate whatever sensor you would like in real time to the Spotter platform. So André will be talking more about how he's done this with the Bristlemouth Dev Kit, but we can look at various different sensors such as turbidity, acidity, CTDs, other types of acoustics, cameras, for example. And we have a lot of people who are actively and currently integrating sensors as we speak. So if you go to the bristlemouth.org website, we have a forum on there where people are communicating and sharing information and ideas, as well as our engineers being on that website, sharing all of this information. So you can start your integration and be as successful as possible by communicating, sharing, informing each other about the integration process. So we have that platform available there as well. The smart mooring goes down to 50 meters in terms of real-time data. If you would like to deploy in deeper locations, you can add a conventional mooring from the anchor node all the way down to the anchor, but we're limited to the 50-meter cable lengths at the moment. As I mentioned, you can view the data either via a dashboard or the API. We have a lot of documentation on the API if you wanted to create your own interface. And towards the end of this presentation, I'll actually show you an example of some of the dashboards that our customers have already created. But this is Sofar's own dashboard. It's completely free to access if you own a Spotter Boy. And you set up your Spotter Boy on this dashboard and your data starts coming in real time. So on the left-hand side, you can see multiple different data points. So if you have multiple spotters, you can see them all in one place and manage it through there. You can see all the data coming through in real time. So on this dashboard, if you go to the historical data, you can see all of your historical data that's stored on the cloud at any moment in time, even if your spotter is not deployed. And then in the settings, you can communicate to and from the spotter. So if, for example, your spotter is out and deployed and you want to change the data mode, you can do this all remotely. You can also set up parameter alerts, GPS fence, and other notifications in the dashboard as well, which will send you email alerts so you can actually respond to some of these alerts all in real time. So that's just a quick background of Sofar and what we do, just to give you a bit of context, especially when André and Tommy start talking about their applications. So today's speakers is Dr. Tommy Bornman from SAEON, which is the South African Environmental Observation Network. We're going to use SAEON for short, because otherwise we'll be here forever. And André Hoek, who is the technical lead at STS, which is Sea Technology Services. So I'm just going to pass it off to Tommy.
Thank you, Jasmine, for the introduction. Yes, as Jasmine said, I'm from SAEON. Next slide, please. So SAEON is mandated to establish and maintain long-term observatories in the biomes and bioregions of South Africa and its surrounding oceans. We're also mandated to provide research infrastructure platforms to the scientific community, ultimately to benefit society. So SAEON has 4 terrestrial nodes, 2 marine nodes, and a data node. I lead up the coastal node of SAEON, and we're also tasked with the implementation of the shallow marine and coastal research infrastructure, one of the 13 research infrastructures funded by the Department of Science, Technology, and Innovation. Now, in South Africa, our coastline is nearly 3,000 kilometers long, so we cannot observe that entire coastline. So we've taken the sentinel site approach, where we intensely study, research, and instrument selected sites in selected bioregions around the coast, and then hopefully apply that knowledge to the rest of the bioregion. So those sentinel sites, you can see in that little schematic, are those polygons in lighter blue, around the coast of South Africa. And then we have satellite sites in between those sentinel sites on the mainland, extending also down to the subantarctic islands. And we also, over and above these sites and the instruments in them, we maintain a suite of research infrastructure platforms such as airborne remote sensing, coastal craft, biogeochemistry laboratories, etc. But that's not the purpose of today's talk. If you want to learn more about what we have accessible and you can provide, you can just go to that website I indicated on the previous slide. Just Google SMACRI or SAEON. But just a brief background for those not familiar with South Africa's marine environment. South Africa is characterized by 2 synoptic scale oceanographic features: the warm Agulhas Current on the east coast and the northward flowing cold Benguela Current on the west coast. And both of these are globally important eastern and western boundary currents. And next. South Africa is also characterized by highly productive coastlines, as you can see in that satellite chlorophyll image. Next. And this high productivity is mostly caused by upwelling, driven mainly by the currents as well as wind. Next slide. And if you look at the cross profile of an upwelling event, this is from one of our UTR strings in 30 meters of water, you can see the incredible variability in ocean temperature by as much as 14 degrees from the surface down to 30 meters in depth. And you can see in there also, often these upwelling events do not breach the surface. So you cannot only study upwelling events using satellite data. You need in situ moorings and instrumentation to really get to grips with the structure of these upwelling events, the drivers of them, as well as the biological response. Just another aspect I want to mention is our coastline is exposed to the Southern Ocean. So during big Southern Ocean storms, large swell shoals on our continental shelf, which can result in significant wave heights in excess of 12 meters. So this is an extreme environment for us in which to work and to deploy moorings. Next slide, please. This is a map of one of our older sentinel sites that we started in 2008. So each of those symbols that you see there denotes a in situ mooring, continuously recording every hour data on currents, waves, temperature, salinity, marine organism movement, etc. A shortcoming of this sentinel site is that not a single one of those instruments has a surface expression. So none of them are near real time. You can access the data near real time. So if someone wants the data, they need to wait 3 to 6 months for us to go out there, service the instrument, download the data, do the quality control, and make it accessible. Very useful data that has contributed to a lot of international research projects. And originally, the reason we don't have any near real-time data was originally because of the cost, but also whatever's on the surface is prone to be vandalized, stolen, hit by ships, or damaged by winds and waves. We do have the funding now through the research infrastructure grant, and we hopefully through this talk we're going to tell you what we are planning for our near real-time mooring network. Next slide. Okay, I probably am preaching to the converted. Why do we need real-time data? So I'm just going to highlight a few points. We deployed a spotter buoy 6 months ago in one of our sentinel sites, and we already have used it to improve our sampling effort. We can check what's happening in the ocean and target specific oceanographic events. Our shallowest UTR on our thermistor string is in 10 meters of water, so we cannot really link that to satellite data products, whereas if you've got a surface buoy, you can have a temperature sensor quite close to the surface. And then that map you see on the top right-hand side is from the Data Buoy Cooperation Panel. And those are all the coastal real-time moorings in the world. It's probably a bit outdated now, but major gaps in Africa, in the southwestern Indian Ocean, Southern Ocean, and eastern South Atlantic. So if we can roll out a near real-time network of moorings, we can contribute really valuable data that can make a difference in global studies. Another real benefit of near real-time mooring is validation of models. At the bottom right corner is the South African Weather Service's marine forecast of significant wave height, and that is entirely model-based. There's no real-time data that really contributes towards those models. So having real-time data available can significantly improve the accuracy of these types of models. And of course, there are numerous societal benefits. I'm not going to go through all of them, but harmful algal blooms are increasing globally as well as in South Africa. So the ability to detect in near real time the start of a bloom as well as its spread around the coast is very important. Next slide. So South Africa has a very long history of mooring development and deployment. South Africa currently has moorings in the southwestern Indian Ocean, the Southern Ocean, not only coastal, deep offshore moorings as well as in the Atlantic. And most of these are subsurface moorings, but our government organizations such as Department of Forestry, Fisheries and the Environment, as well as CSIR, have in the past developed real-time moorings. Unfortunately, none of these have been sustainable in the long term. I don't think really it was a case of cost of these moorings, but rather the cost of servicing and maintaining these moorings in the long term in a very harsh environment. So now we do have the resources and the teams to maintain these, and hopefully we can start rolling out this network. Next slide. So our plan for the South African Coastal Observation Mooring Network is to continue to maintain our delay time moorings, but also expand it because they are relatively cost effective and easy to maintain, and then supplement them with a suite of real-time moorings. And we are busy rolling out these 3 different moorings in collaboration with our technology partner, Sea Technology Services, and André. And he will speak more about what they're doing, but specifically on the spotter buoy. So they're assisting us with the development of these large met ocean coastal observation moorings, but they're very costly. They will measure every EOV, ECV, EBV that you can think of. But because of their cost, we will only deploy around 4 of these around the coast, and then interspersed, because they are more affordable and they're more durable, we will have these spotter buoys, what we call our coastal observation moorings, around the rest of the coastline. And then Andre is also busy with some other interesting R&D on other moorings, but that's possibly for another talk. Next slide. So this is what our network we are proposing to look like. So we will have these 4 large met ocean moorings in St. Helena Bay, False Bay, Algoa Bay, and Utugela. These sites were selected specifically because they are within the interface of the land-ocean aquatic continuum. So they form part of an catchment coast research studies for the future. And then interspersed, we'll have all these between 26 and 30 of the spotter buoys. The spread of them will ensure that we will cover all the bioregions and ecoregions in South Africa. But the network will also enable us to detect and look at the movement of extreme events, whether storm surges or harmful algal blooms, marine heat waves, or cold snaps. Next one. So earlier this year, as I said, we deployed our first spotter buoy in Algoa Bay at the Sundays River. This spotter buoy had a temperature sensor near the bottom at around 27 meters. another temperature sensor with the ADCP at around 11, 12 meters, and then a spotter and a temperature sensor near the surface at around 2 meters. And we were very interested to see how well the spotter captures these oceanographic events within our coastline. So we compared it to a UTR in close proximity to it. Next slide. And this is our results. So the UTR on the left-hand side, the spotter data on the right-hand side, and you would agree at first glance, we are very happy with the data produced by the spotter, very similar to the data produced by our UTR line. There are subtle differences. So if you look at the UTR top panel, which is February, and you look in the middle of the water column, you can see a lot more structure there and detail that is absent in the spotter buoy. And the reason for that is we've got a logger at 20 meters, 15 meters, and 10 meters in the UTR, whereas the spotter only had one logger situated at around 11 meters. So it missed some of that detail. But if you look at the spotter again, the middle two panels, the spotter has a logger at 2 meters. So it captures that heating of the water surface, which our UTRs do not, because those warm surface waters didn't extend down to 10 meters. So we're very happy with the data produced by the spotter. We would like, as all greedy scientists normally do, more sensors, temperature sensors along the mooring line. Another shortcoming is that because it's a surface mooring, the mooring cable is long to take into consideration tidal exchange as well as large wave events. So the problem is if the current is running strong, we don't know at what exact depth a temperature sensor might be. So we would really like a pressure sensor associated with each temperature sensor so that we know exactly at what depth those temperature sensors are. Next slide. And this is my last one. So our future plans, we have already pre-ordered 5 oxygen sensors, and we are hoping to deploy them on these spotter buoys that will be deployed in areas prone to harmful algal blooms that often have these deoxygenation events when the blooms go into senescence. So we'll probably deploy those on the west coast and south coast of South Africa. We are hoping to deploy as many ADCPs on these spotter buoys as we can, especially in areas that are data sparse. And then lastly, we want a temperature sensor as frequently as possible along that line. And this brings us to the next talk, which is André's. And they developed a thermistor string for us with a temperature sensor every meter. And we deployed it for 2 weeks, just took it out last week, Thursday, but I'm not going to steal your thunder, André. I'll let you talk us through the development of that mooring. And then lastly, so just one thing, André, please put a pressure sensor on all those temperature sensors as well. And then lastly, our website and databases. We also developed our own website. So we harvest the raw data from the Sofar site, analyze it and make it visible on this site. All our real-time moorings will go to this site. We also apply quality control to the data and then load it on our observations database, which forms part of SAEON's open data platform, which adheres to the FAIR principles. So it's freely and openly available to anyone. You can just search SAEON observations database or SAEON data portal, and it will take you right there. And in the future, hopefully, we will also develop some applications where some of our stakeholders will develop like early warning systems of marine heat waves or harmful algal blooms, etc., based on the real-time data that comes out of this network. Thank you very much. So I'm going to hand over to André. André and his team is amazing. If you've got a problem or a challenge in the marine environment, just ask him and you will find a solution. Thank you.
Thank you, Tommy. Yeah, let's get going. So we can advance, please. So my name is André Hoek, and I'm an electronics and software engineer at Sea Technology Services. We're celebrating 25 years this year, and I've been there for 17 of those. Like many engineers that stick around for too long, I've become a leader of a herd of nerds instead of doing engineering myself. But I do try and get my hands dirty as often as possible. I love going to sea. I love building things. I love robots, the ocean, crazy scientists, I mean ambitious scientists, guys that sort of push the border a bit and do new things. And a fun fact about myself, I'm petrified of presenting webinars, but here I am. That picture on the left is what the best day at the office looks like. This is just sort of a yeah, you can go to the next one. This is just sort of a snapshot of no, one back. That collage. That's it. So this is sort of a snapshot of things that we're involved with. So if you start top left, we do everything from circuit design to board layouts to actually producing the boards to writing software for them. We do a lot of camera work. We do a lot of things to GoPros, especially that void their warranties. We make them last for 4 months at 1,000 meters and all sorts of other interesting things. We work a lot with autonomous platforms. So you can see 2 sea gliders at the top, buoyancy gliders, various brands. We manage a fleet of those, Slocums, wave gliders, and others. And then we do a lot of sort of bespoke, interesting projects. The blue tube you're seeing on the right is a little phytoplankton incubator, programmable incubator. And then that surfboard looking thing left of that is a very interesting project that we just did for surface scientists. So that's a prototype that was presented in France last week. A lot of fun. Left of that is one of the places we work a lot is in the Southern Ocean. So that gets quite spicy. Left of that, we do a bit of in-house fabrication, smaller things. And then, like I said, everything from drawing on a napkin with a scientist to building the thing to taking it and supporting it at sea, we do all of that. We also do some sensor development. So if you look at Table Mountain, you'll see a wave glider in the front. And this was a test for a PCO2 sensor that we developed. And on the right, you'll see some of our guys doing field support on the SA Gallus, our polar vessel. So we're very involved with the vessel, everything from when it was built to writing the underway software and some other things. And next. So Bristol Mount and the Pioneer program. So we applied to be part of the Pioneer program in October, I believe, 2023. And soon after, we heard that we were successful. And a month later, our development kit and our spotter arrived. So that was an early Christmas for this bunch of nerds. Very exciting. But a spotter is no good in the lab. So the very first thing on the very first day we did was to run out the door and put it into the harbor. On the next slide. So we're lucky that we've got access very close to the office. So you can see again, Table Mountain in the background and my handsome assistant helping to deploy there, Sean. And then the next slide. And then Jasmine, you can decide what a few moments are. There we go. So this was a real light bulb moment for myself. So literally putting the spotter in the water to getting this sort of data was 5 minutes flat, no sweat. And for us, that's a huge opportunity. What it tells us is we get all the things, we do a lot of projects where you sort of have to build all these building blocks from scratch. You know, your data transfer, your power management, like all the basics that you need to repeat. And what the spotter did for us is it takes care of all the basics. It basically becomes a data truck, and we can focus on what we're good at, developing and integrating new sensors. And on top of that, you get this bonus measurement of waves and wind. Next. So Jasmine spoke a bit about bristle mount, but just sort of a quick summary again. It's an open source protocol and hardware standard for creating modular plug and play underwater sensor networks. For people in the industry, you might know instruments from different manufacturers don't always play nicely together. So this is an attempt to sort of bridge that and make it easy to integrate things. Next slide. This is sort of our experience, the learning curve with bristle mouth. So the first thing that we had to do is just get familiar with actual protocol. It's quite a chunky document. It's very well documented, but it's not a quick one. And then sort of the next step was firmware development. And again, it's quite a learning curve if you haven't done this sort of thing before, just getting set up with your SDK. And as engineers, we believe if we can have a LED flashing, then you know your tool chain is working. So that process is quite a steep one. But again, very well documented and very well supported in the forums. And then the next step was the hardware design that we're quite used to, same with system integration and the same with testing and deployment. Next one, please. So this was our first integration. And this is sort of the basic spec that we started with. Is we wanted a thermistor string with 10 individual nodes implemented as a single bristle mouth sensor. We aimed for an accuracy of 0.1 degrees. And we also added a pressure sensor close to the seafloor so you can get some tidal data. And then we wanted the software to store and get some statistics and then send that data back via the spotter platform communication. And then at the end, retrieve that data and visualize it. Next. So this is the hardware design and qualification stage. So on the left, you can see the development platform lying on the bench. So you can very quickly sort of wire things up and start testing. And the little green circuit boards you're seeing there are our individual nodes. So there's some intelligence in there. And below that is our very scientific calibration check with our beer cooler. So what we did is we tested our thermistor string against a Seabird scientific reference sensor. And we ended up with about 0.07 degrees accuracy. So we nailed our accuracy spec there. Next. So then it came to actually building the hardware assembly. So top left, you can see one of the nodes that's integrated. So we had a long thermistor string with those 10 nodes integrated. Below that, you can see copper sleeves that we used for anti-fouling. So we don't have issues with fouling for long deployments. And then top right, you can see things coming together. So that's the spotter development platform. And if you look closely, you'll see the black wire with the nose sitting on it. And below that, you can see the pressure sensor that sits at the bottom, integrated with the development kit. And on the right, you can see the intern terrible job fixing the whole thing together. Next step. Right, so next step was to do a quick leak test, which we did indoors. A ridiculously oversized anchor that we had, and we deployed and hold thumbs, and then next. And this is what we got back. So I think we left this out for about 3 days. We were very lucky that it was right next to our research vessel, so we had access to things like temperature and what the tide was doing. So it was nice for validation. So you can see on the right there, we had a cold front moving through. That's the blue blob that you're seeing. And then on the right, you'll see the bristle mouth explorer. That's a very nice tool developed by Aqualink. That's very useful for when you start debugging and you want to see your custom messages coming through. So definitely a resource worth checking out. Also, the API is very well documented. Our tool of choice is Python. So between Python, the API, and ChatGPT, even engineers can make pretty user interfaces. Next slide. Then these are sort of just fun things to think about moving forward that I think might add some value to the ecosystem. I hear you, Tommy, on having pressure on every temperature sensor. We'll do that. But this is sort of a scenario we're thinking about where if you start on the left where you have your normal spotter platform, and then right next to it, we've got not a spotter, but we can integrate various things. And we're talking about this on the Bristol Mud Forum as well. And some other users have similar needs where we can have different sorts of communication channels. When you're closer to shore, something like LoRa that uses very little power, so you can have lots of nodes talking to it, some additional battery. And then number 3 is something that I think could also add a lot of value, is a cost-effective slip ring where you can actually have your nodes directly connected to the bus, and the spotter can still move and do what it needs to do, but you have your stable platform at the bottom. And that opens up a lot of opportunities for seafloor mounted payloads, things like ADCPs and cameras and other power systems. Then number 4 is, again, just something fun to think about, is some sort of profiling interface, whether that's buoyancy controlled or some other mechanism on the bus. And I've got an unsuspecting German intern that I might let loose on that one. And then on the right is something Tommy talked about earlier, is where we have sensors directly mounted onto kelp. And again, it's one of those cases where we had to design everything from scratch, our power management and the data transfer and all of that. And in this scenario, where you have different comms at the surface, it's a perfect situation where you can have a lot of sensors, say in a kelp forest, talking to one spotter, taking that data and sending it back through the API. Yep, that's me in a nutshell. Thank you very much.
Thank you, Andre. That was super informative. Thank you both, Tommy, as well. So just a quick reminder for anyone that has any questions for Andre, Tommy, or myself, please put them in the Q&A box at the bottom of your screen, and we can answer those towards the end. I'm just going to quickly cover over some of the other environmental networks that we've been working with, just as a few examples. So while you're typing out your questions, I'll be running through some of these applications. So I think Andre already mentioned Aqualink. They were actually putting systems out around the world, and they have their own website and dashboard interface, and are deploying spotters and trying to do a lot of conservation work, especially with these coral reef networks that are massively under threat. And we work with various different sections. So actually Mission Iconic Reefs research and monitoring in the Florida Keys. So they've got a variety of different platforms deployed. So you can see from the maps on the right-hand side, those are all different spotter deployment locations. So really easy for people to deploy rapidly, low cost, so that we can do more monitoring. You know, any scientist will tell you this, more data is better. Obviously, I think Tommy's just been saying this as well. We also work with IMOOS, so they are creating a network of spotter buoys around the Australian coastline. So they're the integrated marine observation system. So they have a variety of spotters, smart moorings, but then also other observation buoys around the coastline. So using spotter as a supplement to those as well. All of that data will be coming online for free. It's accessible as well, and creating more of a national scale. So obviously Australia's got quite a vast coastline as well, as South Africa. So that's really important, especially for a variety of different applications. For example, Tommy mentioned a couple that were really important for the coastline and the blue economy. We also have a project with backyard buoys. I have to say buoys because my company is American, even though we say boys. They provide buoys to Indigenous coastal communities, so people that may have never seen a buoy in their life are deploying these and actually absorbing the data. So the spotter data comes in a very digestible format. So these communities can actually respond to that instead of having to do post-processing, etc. So being super low cost, easy to use, and actually having that digestible data has been a really important and key aspect of this particular project. It continues to grow. So this has been going on for a number of years now, and it's going to continue to grow to make obviously a much larger network as we continue to get funding and support more of these isolated communities. The data is also absorbed by scientists and it helps with local applications such as fishing, etc. So this is really important for a variety of different applications as well. And like I mentioned, Aqualink earlier, this is their observation network that you can see around the world on the right-hand side, and their online dashboard that they have available at the bottom right. So they use our API to do that data display there. Same as before, they use a lot of citizen scientists to do these deployments. So people that may have never seen a spotter in their life are deploying spotter smart mooring systems as well. And also, you know, having these networks not only on like a local level and national level, but then also now on a global level as well. So I'm going to stop here because I'm sure there's going to be a buzz of questions. So this is a nice slide just to end on. I see some questions coming in. If anyone else has any more questions, please put them into the Q&A box so that I can ask Andre and Tommy now. So I'm just going to stop sharing and we're going to go to a few quick questions now. So I've got a few questions here. I'm curious if there are any plans to incorporate biological indicators in the future to eliminate ecosystem processes. So chlorophyll is a great step forward, but also eDNA through meta-barcoding or metagenomics could be a powerful complement to our already robust platform. Yeah, so I will say just from a Sofar point of view, we're always looking to integrate more and more sensors onto our platform. So if you guys have any sensors that you'd really like to see in real time on the Spotter platform, please let us know. The more we know about your applications and the more interest we're seeing from our customers, the more we have a use case to actually start integrating more and more. There will be new sensors coming out next year, so please keep an eye out. There'll be more and more webinars coming out to explain those as well. But yeah, Andre and Tommy, what sort of sensors are you interested in seeing in terms of real time? Obviously, I know, Andre, you'll be doing a lot of integration work, but also from you, Tommy, as well, as you continue to grow the Australian network. Sorry, South African one network. Tommy, do you want to go first?
Yes. Yeah, no, I can go first. So yes, we're also definitely very interested in chlorophyll as at least a first step towards collecting biological data. But eDNA would, you know, is the way that the world is going. So that would be the logical next step after chlorophyll A as well. I suspect that these would, you know, they will have wipers on them and reagents, etc. So they will be quite energy intensive. So you'll have to look at something like what Andre has been suggesting is alternative energy sources. Because unfortunately there's just not enough energy in a single spotter buoy at the moment. I don't know, Andre, if...
Yeah, from our side, we're very much led by the science. If you let us loose doing our own thing, you'll get some interesting sensors. So it's very much answering the science questions that drives what we work on.
Great, thank you. I also have some other questions for you guys. So Andre, what are some of the potential use cases for the Bristol Mouth enabled spotter with the node thermistor string? So what are some other use cases that you could potentially see this being used for?
So again, I think it's something that needs to be driven by the science. We do have a lead. I don't want to mention names because I don't want to get Jasmine in trouble, but that we might be able to use this in the fisheries aquaculture industry. So that's one potential application.
That's great. Yeah, you won't get me in trouble. I'm sure we'll be okay for the time being. But yeah, that would be a really interesting use case if the two of us can actually pull that one off. Tommy, for you, how do you envision key stakeholders using not only the data from the spotter network, but also these other data sources and platforms that you mentioned as well? Oh, is Tommy dropped off? Oh, okay. I think Tommy might have dropped off, unfortunately. Great timing as per any webinar, but that's perfectly fine. All of your questions I will be passing over to Tommy and Andre, and any questions that are in the box. I'll answer a few quickly now. There's a question about the 50-meter max depth of the smart mooring. We're just limited, obviously, by cable lengths at the minute. This is something that might potentially be addressed in the not so distant future. And there's also other applications around it instead of using cables. So watch the space. There may be some more things. It's just because of the applications that we've been working on. It just made it slightly easier to get more and more data as quickly as possible for the time being. There's a question for Tommy about the spotter data being available on their network. It should be. There are buoys deployed at the moment, but there will be more buoys being deployed. We're shipping a couple more units to them towards the end of next month. So there'll be more and more being up on that website as well. How often do you have to replace the battery of the spotter buoy? You don't. It's completely solar powered. You don't need to change out the spotter battery ever. It's continuously rechargeable. So there's no real requirement there as well. So there are a few other questions about various different sensors as well. So please keep adding those into the box there. Like I said, after webinars, sometimes you talk to colleagues and start having discussions and more questions pop up. Please do reach out to us. We'll send you a follow-up email after this webinar anyway, so you can just respond to us and we can get those questions to the right person and get those answered for you. But again, I would really like to thank Tommy, who's jumped off, clearly got some other stuff to do, and Andre for joining us on this webinar today. I really appreciate it, even though you have an absolute phobia of webinars.
It was a pleasure. Thank you.
Great. Thank you so much. I hope you all have a lovely rest of your day, and we really appreciate you joining us this week on this webinar. And if there's any questions, please do follow up. And again, if you would like to speak to Andre or Tommy, please reach out to us and we can put you in contact with them as well. But yeah, thank you so much, and speak to you guys all soon.
Thank you, Jasmine.
Thank you. Bye-bye.